Any containers? There we go. Hello, I think we'll get started on the next session. So the link for the Etherpad is off the schedule. It's right there. OpenDev dash container systems. The ask this morning was to talk about containers and Kubernetes on the edge. Similar to how we ran the session yesterday, if you guys want to add topics in here so we can make sure to get them covered, we'll upvote them, we'll go through them. I have some that are of personal interest about, I know in the last use case session there was a section in there for about how are we going to deploy different deployment models, what they look like, examples. I can talk a little bit about what we do today, about what we're thinking of doing, but I would love to hear from you about how are you thinking about this world where containers and what we're doing with OpenStack and infrastructure are converging, and how you're approaching the problem set. I think there's also a great presentation from AT&T, I'm not sure where they are right now, about how they're doing the converged stack with the Helm, the Kubernetes underneath, and running some stuff in Kubernetes. Some of the things, too, that I'd like to see is how are we solving persistence and network functions in Kubernetes, if that's what we're looking at as part of the platform out there. But feel free to add or speak up, and we can add to the Etherpad if you have other topics you want to bring up. Any topics right now? It's the Friday afternoon crowd.
How about, actually, I have one. How do we convince vendors that it's a good idea?
How do we convince vendors that it's a good idea? Exactly what is a good idea?
Converting to containers.
Oh, converting to containers. OK, thank you. Any other topics people want covered? We'll put that one on pad.
I'll be more explicit about it. So we're working with a bunch of vendors, like security vendors, and they all have VMs. None of them are containerized. I'm talking about application vendors. So
yeah, so network, that's valid too for network functions. A lot of them right now are
zero.
Yes.
So let's make it easy.
Yeah. Okay.
Andrew.
Yes.
Infrastructure management.
Infrastructure management. Like, go ahead.
So putting containers out on the edge. If you're putting containers out on the edge, there's got to be some sort of infrastructure you're putting it out there. If you're putting it on bare metal, how are you going to manage the bare metal? If you're putting it on VMs, are we, we're assuming we're working with OpenStack. What are we doing? So infrastructure management at the edge for containers.
Sure.
Whoever's typing in green, please put your name up top.
Yeah, in the top right, if you're not familiar with Etherpad, where that 12 is right now, you can add your name. Go ahead.
So, three things actually. One is the performance with containers, performance, availability, and also security.
Okay. Performance, availability, and security.
Thank you.
All right, so if you're on the Etherpad, if you can +1 the topics you want to go through, and we'll address the topics by the ones that get the most votes. Yes, this is a session where it's better to have your laptop out versus a typical session. We can take votes too, since we don't seem to be getting a ton of digital participation. How many are interested in? When we say how are we going to deploy deployment models, is that for the application or is that for the control plane and infrastructure itself?
I typed that because you said it.
Okay. Put it back on me. Fair enough. I'm thinking for scope of this, let's go with for the infrastructure itself, which I would tie that with number 5 then. Persistence, so how many are interested in infrastructure management / deployment of how we manage the infrastructure, how we deploy the infrastructure? 1, 2, okay. Persistence in network functions. Persistence and network functions, not in. I was like, I'm trying to understand that one, but yeah. And network functions. Basically, workloads, addressing workloads that aren't supported, which kind of ties in with Best's number 3. How do we convince them? I think that's the same topic, 2 and 3. We can combine them. Yeah, supporting stateful workloads in Kubernetes, right? So part of, I guess maybe I'll paint a picture of the challenge that we see, right? Is if we're going to run containers at the edge, do we run everything in containers? Right now, if you actually talk with the Kubernetes community, they actually recommend that you run your stateful workloads outside of Kubernetes, right? And so your database, whatever it may be, is running on a VM or whatever, or it's managed, service outside of Kubernetes, and you run your stateless app inside Kubernetes, right? That's kind of the prevailing advice in the container community today. If my perspective, if we're talking, at least in our world, a relatively small edge platform, I don't want to be running multiple flavors and types of infrastructure just because one is supported, better than the other. I would like to standardize on one. And if it's containers, and if we're talking Kubernetes, that's why I'm interested in running both like storage, like persistent disk, as well as persistent databases, as well as things like network functions, all within the same platform. So how many votes for convincing the vendors / talking about persistence and network functions? 1, 2, 3. You can count me. 1, 4. An existential question: is converting to containers a good idea?
On small boxes, yes.
Well, that's what I'm raising it as a point for discussion, not to actually discuss it quite yet. So who wants to discuss that? How many votes? Hands? Quick show of hands. 3. Bare metal or work with IaaS? How many are interested in that topic? 1, 2, 3. You got a lot of 3s today. It'll be fun. Control plane resource utilization. Is that managing the utilization? Like,
Control plane resource utilization. Type that.
can you, short explanation?
Okay, like OpenStack, Kubernetes also have its own control plane stuff.
Yes.
Like Kubernetes, and also it's Kubernetes proxy, the network plugins components. How much resource utilization it will take if we put it on the edge, especially for the resource limited nodes. Yeah.
Got it. The overhead of the control plane.
Okay.
Right? Yeah, okay. How many are interested in that topic? Overhead of the Kubernetes control plane. 1. Okay. Performance. Who had a performance? Oh, those are separate. The performance, availability, security. Performance, when you say performance, you're talking about Kubernetes itself, or you're talking about performance in a container? How does an app in a container perform versus an app in a VM? Okay. Okay. Performance, availability, security. Who wants to discuss that? How many? Raise show of hands. 1. All right. Last, mixed setup, container plus VM. I guess we're asking, is that a good idea to run both? What are the positives and negatives? I mean, that's definitely a possibility. So how many want to speak about that? 1, 2. All right, 2. All right, so our clear winner is deployment models / infrastructure management at the edge. All right, let's start that one. Number one, I guess it's combined with number 5, right, we said? So how are people looking at managing their infrastructure at the edge today? So like from our perspective, I'll share a little bit of what we do is so we're deploying, let's say Kubernetes up to like 40 or 50 sites. Right now, those are actually all managed individually. I don't have a good solution there today, right? We're using Ansible plus Terraform to deploy. We push out Kubernetes there, but I don't have anything that's really grouping them yet or managing across those clusters. And so those are some of the problem sets and some of the areas we're exploring. Do we actually work on new open source tooling to manage across that? And we want to scale to thousands, right? So that's the kind of picture that I'm looking at is, you know, what gives us a good picture of the health of hundreds or thousands of clusters. Shouldn't matter whether they're deployed on VMs or deployed on bare metal from our perspective, but managing that high number of clusters, keeping them all up and running well, stuff like that. You have something?
I've been in discussions lately, you know, some of them get pretty heated, but it's, you know, why would we deploy containers in VMs on OpenStack on the edge if we want to go that far versus deploying containers, Kubernetes on bare metal? And my first question to them is, if you do it on bare metal, how are you managing your infrastructure? So I've had, you know, answers like, well, I'll just put Cobbler out there, and then I'll do it with Ansible scripts, and then Terraform, and then I'll run some Puppet, and then, you know, and I said, well, it sounds to me like you're writing your own infrastructure management platform. I know one that's pretty good. It's called OpenStack. You might be able to use it. So it's kind of this cyclical argument. I think that when we're talking, like you said, thousands or tens of thousands of edge nodes, we need to seriously think about how we're going to manage all of this infrastructure.
Yeah, I'll throw in a comment. So in the data center, we are doing ironic and doing Kubernetes on top of both VMs and on top of bare metal when provided. But we're not doing that in our edge cases today. So that's a very fair question. Anyone else have thoughts on how they're approaching that or thinking of approaching it?
Can we be a little bit more explicit about what we mean by management? So let's break them down. First is the provisioning. Are we talking about the provisioning of each edge component? Are we talking about the configuration, provisioning, and then the fault management? So if something goes wrong, then I can identify the problems, troubleshoot, and then figure out and fix it. So can you explicit on this? What do you mean by management?
Any other feedback? You want to say?
Management for me is, at least in this example, is deployment of the, you know, bare metal asset. So it's after they're racked and stacked, you know, the equipment's there on the edge. How do we image it? How do we get it set up? How do we get it ready to accept workloads? It stops there, and then that's, you know, that's day zero kind of operations. Day one then would be loading the application, and then day two would be then operations. So I think all of those need to be answered, right? But the one I'm answering right now is, how do you handle day zero management?
Any thoughts or feedbacks on that?
Maybe I'm not understanding the question, but it's how do you get ready to accept workload is bare metal provisioning, right? In terms of laying down an operating system, making it ready to deploy a workload to using one of the various tools. Is there more to it than that? Or?
So day zero is bare metal, as in right off, you know, racked and stacked, just power to it, maybe network connections done, all the ticked and tied. So that's day 0. Loading it with an image and putting on the Docker tools, all the Kubernetes agents, putting everything on it that we need to do to get it ready to accept its first container is day 0. Then deploying the applications would be day 1, and then managing the applications is day 2.
Yeah, you can add a link on the Etherpad. So, I mean, I actually think that this is an area, not so much in the bare metal. I think there's enough tools out there that, whether it's OpenStack or in Ironic or other things, to handle bare metal. But for the deploying of thousands of Kubernetes nodes, or frankly, deploying thousands of OpenStack environments, I think that piece is still kind of an unsolved, to give kind of an overall health management, the day 1, day 2 ecosystem around all that. Like I have a relatively small team managing our current edge with thousands of nodes because tooling has matured in that space. How do we get to parity in that tooling in the open source infrastructure space is, I think, a question that we do need to dive more into. Maybe not right now, but I think that's one of the areas that we have to evolve. We can't scale massive teams just to run thousands of edge nodes. And so we need to mature some of that tooling, right? And also do things like correlating. So right now, like for example, when our network, our WAN goes down, that's a completely separate set of monitoring than what we're doing for our infrastructure monitoring, and we're not correlating those events today, right? And so that creates extra work, manual checkup, all that type of stuff. Anything else on this topic, or should we move to the next one? All right, the next one is the persistence and the, how do we convince vendors that converting to containers is a good idea? Sure.
So this is actually a real world problem for us. So we're working with a bunch of security vendors, network services vendors in general, although I think it would apply to any application vendor. But security vendors, I think, are the ones that are particularly nervous about it. So unlike where you own the app and you're creating your own app, so you can make the decision whether to containerize it or not, we're working with third-party vendors, right? So we have to convince them that it's worth their time and effort to containerize, and it's secure enough, that it's to containerize their product, and that they will get a benefit out of it to put in that development effort. Part of the, give you an example of why this is important. So network services vendors up until quite recently, I'd say about 5 years ago, had no virtualization. It was all appliance based, and then Amazon, yeah.
Service providers were traditionally what?
Appliance based. Yeah. So Amazon, came along and created the marketplace, and the deal with the marketplace is it had to be virtualized. So the vendors then stepped up to the plate and said, oh, well, okay, there's an opportunity here. If we virtualize, we can put it in Amazon. So I think we need to create sort of a similar kind of motivation to get them to containerize.
So I don't think the Edge Computing Initiative guy was here that works with Professor Satya, but I did have an interesting conversation with him earlier, so I'll speak on his behalf slightly. But I think that was kind of the story that he was trying to tell in that initiative, because I agree, for this to work, there needs to be, and standard is a strong word, but an ecosystem, a common way of looking at Edge, to point those vendors towards saying, hey, there's a bunch of us in a different, and I think this event too is a kind of a good platform for that. But there's a bunch of us in different use cases in different sectors that are looking at doing these things, and we all want to do them in a relatively similar manner. We're all starting to seriously consider containers, Kubernetes, whatnot. And if you want to be part of this bandwagon, you need to get on it and deliver your function or your service as a container. And I think also collectively, if we start to put pressure on the same, like I think I've had already a few conversations about putting Ceph on top of Kubernetes and what does that look like and how are we going to support it and whatnot. Same thing with some of the network functions that we consume. Like we can push in that category, and I think we need to do that together. But I'm open for other feedback.
We're talking about Verizon, Walmart here. So you guys put out an RFP, the vendors will respond. As long as there's money on the table, trying to get them into a future ecosystem is going to be hard, right? It'll take 5 years. But if you put an RFP that says within 1 year, I want production quality container-based firewall, I'm sure a bunch of them will bite, especially if it's like 10 million, 20 million on the table.
So what are the kind of workloads for which you would want a container, and what are the workloads you don't want a container?
Yeah. Any feedback?
I think that's just one of the other topics just down below. What do you want to containerize? Why would that be better? Why is a container better for which applications?
Yeah, so you said the stateful one were advised not to be on the Kubernetes. Can you explain why or what?
Sure. Okay. I mean, I think it's a maturity issue in Kubernetes more than anything at this point. It's still young, so like the concept of stateful sets is relatively new. They still have to pin it to persistent volumes below it. When you look at kind of cloud native definitions, right, you don't want to be too pinned or too locked down. So like some of the value that a Kubernetes brings is, right, your container dies, you can spin it up somewhere, it can support some kind of auto-scaling concepts that your workload goes up. If all of a sudden you're pinning to persistent underlying storage, you're starting to defeat some of those principles that Kubernetes brings. Right? There are newer projects that are trying to start to address that. But I'll tell you like real quick example, we tried to put Cassandra in Kubernetes, right? For fun, because and if you want to run Cassandra in a single Kubernetes cluster, it actually runs okay. All right. The problem is when you actually want to span clusters. Hey, I need more than one fault domain, right? Well, guess what? Your nodes can't talk to the other nodes. There is no concept of federated stateful sets today, right? And so you're starting to do all sorts of jury rigging to make that work and scale and support to the point where you've actually lost the benefit of running it on Kubernetes. That's kind of a real short answer. I won't claim to be the expert on the subject, but kind of some of our experience.
So for all of you who want to run stuff in containers, what is the value you see in a container? And can I posit the question the other way around and say, I see exactly 2 uses for containers. 1, they start quickly, and 2, they're a packaging format. Is there a third which I'm missing?
Compression of space.
Smaller resource.
Yeah, smaller space.
Sorry, smaller what space? Memory
Memory.
space. Okay, so let me ask you this. How many?
We have constraints. I mean, that's the whole point of edge computing, right? We have significant constraints out at the edge.
I understand. Now, in how many circumstances are you going to be spinning up as many containers as where this particular memory overhead is going to be significant? Now, most reasonable applications which I have seen in our environment are asking for very, very large VMs, where they ask you for a VM with 32 gig and 64 gig. The total amount of memory your operating system takes in that particular case is piddly. Converting that 32 gig VM to a container doesn't amortize your operating system memory space one bit.
Don't think the memory footprint of the OS. Think I/O, especially disk I/O. 15%, 20% performance degradation on the VM. We can shortcut things with DPDK, but that's going to suck up cores. So network I/O is still a problem. So containers. On the average container, it takes about 2% overhead. VM on the average takes about 15% overhead. It does make a difference. And the question should not be why, but why not? If you have a containerized architecture, you shouldn't have to deploy OpenStack just to run a few VMs, right? So the applications should be relatively portable across whatever compute infrastructure you've chosen, as long as it's relatively standard, Amazon, Kubernetes, or OpenStack.
I'm not arguing your point at all. I'm just asking, what is the benefit you see for a container? I will debate the numbers about the actual overhead, but that's not what we're here for.
Hadoop on containers works. Hadoop on VMs is a pain in the butt. So we made Hadoop work on containers with no overhead, just to get SDN into the picture. Large local company, not going to name names, but that was very easy work to do. Hadoop on VMs is relatively painful.
I submit to you that Elastic MapReduce is a product which kind of sort of works.
Yes, it does, absolutely.
And
once you have a 1,000-node cluster, so you're absolutely right. You can make anything you want to work. There is still an efficiency deficit.
So the benefit you're talking about is approximately 10%?
15%, sometimes 30%, depends on the workload, sometimes as low as few percent, but typically 15% on I/O. On I/O bound, Memory bound, CPU bound, I wouldn't worry about it, but you can run 3 times, 4 times the density of smaller workloads, and you can do I/O intensive workloads easier on containers. It's not that it cannot be done. Anything can be done. It's just easier. When we dropped Hadoop on top of LXR, it just worked, right? No tuning needed to be done.
So I am also expecting the less number of virtual CPU to be used, and also I'm expecting a better performance. So because of the OpenStack layering, I'm hoping that most of them was going to be disappear so that I can have a less delay within the system, and those are very crucial stuff. So.
Sure.
Another thing is that containers are what the developers are using, and it's way more convenient for them to actually publish their code and to really do, to try things faster and in the CI/CD lifecycle. That's what they use. They use containers.
The 10x ones.
VMs, and expect to run them directly.
You're basically saying UnionFS for VMs would be a nice thing.
UnionFS for VM. Not.
It's a distribution mechanism. It's a
Packaging,
very convenient distribution and runtime.
It's distribution, but it's integrated with the development tools. You take Visual Studio, it speaks containers. It doesn't speak VMs anymore. So it's beyond distribution.
I'll just throw in one comment too, is from a density perspective. So we actually have the use case that we want to run a very large number of microservices at the edge, right? And we find that we can get the footprint smaller in the container, right? So on a server with 256 gig RAM, we can run a lot more containers than we can VMs. That use case for us is important.
It's a no-brainer, this one.
Yeah, right? So that's actually one of the reasons that our developers were pushing us to bring a container-based solution to the edge. All right, should we hit the next topic?
I think we beat 2 to death, so we don't need to do this one.
Okay, so what's... What's that? Yeah.
Yeah, topic 3.
Bare metal or work with IaaS? We kind of talked about this a little bit. Anybody have comments on bare metal or work with IaaS? I kind of see us in a world of both for right now, but.
I've seen both sides of it. So I think when working with IaaS, you come back to that same discussion of why would I put containers on a VM when I have a 5 to 10% overhead for the VM running on the same hardware?
Well, maybe we should be specific. So, okay. So we're saying bare metal outside of a cloud system versus work with, like, because we can do ironic, but you're working with IaaS, but it's not a VM.
Right.
Yeah.
I think we've muddied the waters. So are we? If we're saying IaaS, that means we're specifically saying OpenStack, and then when we're saying bare metal, we're
saying OpenStack VMs like KVM or.
Okay.
Yeah. Okay.
Right. So I think we said something earlier about, we talked about that, right? Infrastructure management. If we're going to do bare metal and we're going to do it outside of OpenStack, what would be the benefit of doing that versus Ironic and OpenStack?
Nice.
I think what you get is segregation of tenants. That's all you get, but you pay the price over the overhead. If you want to have a multi-tenancy on the same host, that's, I think, the more natural solution to a VMs to split the split the tenants.
So you bring up a good point. Let me ask a curiosity question. How many people are doing multi-tenant, quote unquote, application, like different application teams running on the same Kubernetes cluster today? You're doing it. On Kubernetes. I expect most are doing it on OpenStack at this point. I meant on Kubernetes clusters. Huh? You're doing it? Yeah, so that is actually why we do it today. So we do single tenant Kubernetes clusters on OpenStack VMs today because we felt the multi-tenancy in Kubernetes was not where we needed it to be.
We run a multi-tenant Kubernetes cloud, and we use Keystone to the tenant system, and use Neutron to separate the different tenant. Each tenant has their own layer 2 networks, and we have our own runtime for the virtualizer container to do the container isolation. Yeah.
Wow.
And on the bare metal, no underlie.
Yeah, so just to add to that, so basically the overhead that you're talking about is what we try to eliminate. So we basically wrap each container as of right now with a very minimal VM process, essentially, KVM or Zen. And there's no guest operating system inside that. So it's a thinned out Linux kernel that's used there just to pull in the Docker image. And so we're allowed to use a single Kubernetes master for multi-tenancy across different tenants.
But they're not sharing worker nodes?
Sharing worker nodes?
Yeah.
You mean like the actual physical hosts?
No, the Kubernetes worker node. The tenants, you're saying you're sharing a master node. You're saying, but the tenant each gets their own master worker nodes, or those are completely shared as well?
The multi-tenant share the physical node, and the containers are isolated by the virtualized technology.
Correct. So to do that, you have to give them each their own worker node. Okay.
Yeah, we also contribute this project to OpenStack Foundation called Stateful. Yeah.
Called what?
Stateful.
Stateful. Cool. If you can add a link here, that would be great.
Okay.
It's off the schedule. Is the Etherpad? Any more feedback? Any other feedback on this topic?
So I'm kind of curious about this multi-tenancy with containers. So I was just going to ask, given that we want them to be very slim and very small resource and everything else, and given that you're using for multi-tenancy, can you give us a little bit idea what kind of resources that you have for multi-tenancy?
Sorry.
Yeah, I was basically trying to figure out the size of the resources for the
Hyper.
Yeah, and also the memory and everything else, because again, if it's going to run at the edge, we want this to be slim and things like that. So therefore, I'm thinking that maybe, okay, I'm not arguing with this. Maybe you want to go with the single tenancy, but if you want to go to multi-tenancy, I just want to have an idea, what you do.
So in terms of memory footprint and whatnot, we can do about 80% of what traditional Linux containers can do, but they're basically VMs. And we can boot them incredibly fast, about under 100 milliseconds. So you get performance, but you get the isolation of hypervisors, VT extensions, all that. And then you get the persistent storage, right? So you don't have to,
So you're running the container kind of more in a similar model that we run VMs. You're not running Kubernetes.
No, we are running Kubernetes. So our stack,
Okay.
the stack cube is Kubernetes bare metal
Okay.
with CinderCef standalone, Neutron standalone, and Keystone.
Okay.
So it's the same mantra as what we heard from the OpenStack community in the summit, which is consume what you need.
Gotcha. Okay. Cool. And so you're saying that this Kubernetes node is actually multi-tenant itself, or is that one per tenant? Look at that. So do you have multi-tenant, more than one tenant running on that?
Yes. Actually, the Kubernetes for the control panel, and we run all the container from different tenant in the same node.
Okay.
Yeah. The Fracty, the runtime machine, can create virtualized container. They are isolated each other by the hypervisor.
Gotcha. Okay.
Is that like Intel's got these clear container functions?
It's similar. We created the project. We announced the open source project in the same month in 2015, and now the clear container is just focused on the OCI compatible runtime, just as the runway part in the hyper container, and we have some collaboration on the runtime and try to get a joint force on the virtualized containers. Yes.
Yeah, so the clear container is using some of our technology already, and we're trying to get an open governance model there so we can actually merge.
Cool. Anything else around bare metal versus IaaS versus, or multi-tenancy versus single tenancy?
Can I add one question on the stack
Sure.
queue? Could we have KVM somewhere to create VMs with the same schedulers and everything? Yeah. So the answer is yes.
Yes.
Yeah.
Cool.
Which answers my question at the bottom, like a mixed setup, because I don't believe all the vendors will move to containers right away. So we're going to have like 10 years of software still being virtualized as VMs. So. Say what?
Repeat it.
The last thing? Oh, it's just that the market's not going to move to containers like this. It's going to take 10 years.
So he's interested in the mixed setup between containers and VM.
So a lot of the vendors will sell some of the VNFs as virtualized KVM machines.
One of the other things that we notice in the edge use case in the telcos and NFE is the kernel. They actually want to bring their own kernel, which is useful for us because you can put in any kernel you want into our hypercontainers or our VMs essentially. And so you have your Docker image as the workload, and then you have your kernel that you might have dependencies on that.
And how's the first part of the infrastructure managed? So deploying all of these different parts, how are they? I saw no, Nova boot type.
We don't use Nova at all.
Right. So what do you use in order to deploy the the node side of it?
In StackKube, we just use the kubeadmin to bootstrap all the systems. It will start a Kubernetes first and use the YAML to bring up all the needed components, include the neutron and the keystone and the Cinder.
Okay. And persistent storage, you're using Cinder with the...
Yeah, use Cinder and Ceph. Yeah.
Okay.
Cool. Any other comments or questions on this topic? Do we want to dive deeper? I think the next one is actually mixed setup container plus VM that you kind of talked about. Do we want to dive it a little? How many are interested in actually running a hybrid, is that the right word, setup at the edge of both containers and VMs? Anybody want to comment on it?
Yeah. We need to do it.
Okay. So you're saying that those that dream of a container-only world are just...
No, there's just no way that's going to happen in the near term. I mean, I think the question really is I think you need to move the applications, and then one of the issues comes is, can you define these applications in an abstract enough form that they could run inside a VM or in a container world? I think in a lot of the network functions we see are require enough separation of stuff that they require their own VM, all these things that they will probably be in a VM environment. But there's certainly new applications that are come along that we want to have a hybrid function in all these places.
And go on.
I could even see vendors deploying like some of the VNFs, partly in VMs, partly in containers themselves, you know. The same way you have stuff running in Windows and Linux and it's part of the same application.
I mean, that's the actual recommended model for Kubernetes with stateful applications, is you deploy the stateful app in the VM and you deploy your app in the container.
It's changing, but
It's changing, but right now, best practice is that.
yeah, it's 6 months old, yeah.
I think just from a single VNF, it's probably not likely, but from any kind of service that will have VNFs from different vendors. Some applications, some VNFs will be in VMs, and some will be in some containers, and so it'll be in the large cases, a mix of containers communicating with VMs. I mean, it's just a mixed set of application deployment environments. It's just one larger service.
Management could be another issue as well. So you may have orchestrated controllers deal with the VM base versus the container base, so that's all possible.
I'm just curious to know if we should look at containers as a low, basically overhead environment where we can spin them off in a dynamic way as we need to. You know, just imagine hundreds of containers can come up and go, basically come up and go down because of whatever service that we're trying to launch. So I'm looking at containers as these low-cost processes that can be spinned off. Is that something is doable?
I think when applications are decomposed and refactored into 12-factor apps, I think, yeah, absolutely, you can get a lot more efficiency. But I've seen people, create containers out of COTS apps, and they're like, 400
monoliths.
Yeah, 400 gigabyte containers, and they go, "Woo! I'm running containers, aren't I awesome?" No, you're running the same thing as you did with the VM, just wrapped in something else, and you're not, there's no performance win there. So just going to containers, that doesn't help you. You actually have to do something with the app. It has to be broken down. So I guess I don't know if that answered the question, but I don't want to give a false sense of efficiency just by going to a different platform.
From our perspective, that's exactly what we're trying to do, is run a large number of microservices at the edge, have flexibility. Some of them might be even short-lived or only run during certain times of the day. Basically, give us more flexibility in managing a very small footprint at the edge. That's actually why we actually started with Kubernetes at the edge before we did in the data center. Anything else on this topic?
Networking options under Kubernetes.
Go ahead.
I have some questions and some current concerns about the robustness and feature parity or feature richness of applications under Kubernetes at the edge, especially when specifying, service ports and tying them to specific nodes, bringing them up and bringing them back down in a resource-limited, small environment. You're going to have quite a bit of anti-affinity rules that need to be placed.
Correct.
If things are coming up and down, so just one of those things.
I think it's pretty well supported right now in Kubernetes. The anti-affinity and the port barding. We're using Calico as a CNI. Overall, it's working pretty well for us. What we are solving for is more the service discovery side, right? Like, how do we know across clusters, I want to connect to stuff within the cluster instead of always exposing something out? Can I federate? And so there's some work in the Kubernetes community being done around federating between clusters. And so we can actually do service discovery across that plane instead of always having to go out.
Right.
And then we actually don't have that problem anymore of mapping to ports and whatnot.
Okay. And I think there's also a point here. We've been talking a lot about telco cases and VNFs, but there are also the IoT cases that we look at too, is where we have hyper-converged nodes that may contain sensors, sensor nodes that maybe talk to these containers that don't have to be exposed to external, but need to talk to each other in a very rapid manner. The pole-connected autonomous car nodes, things like that.
Correct, and then that brings in also machine learning type requirements and GPUs in the nodes. I agree 100%. So when we look at it, it's a converged use case. So we're interested in running all of it.
What about working with performance accelerators such as DPDK or SRIOV, things like that?
Yeah, as far as I know, that's where Kubernetes needs quite a bit of work, but I haven't spent a ton of time looking at it. Even GPU is still an experimental support being able to run it in Kubernetes today. What's that? It's a hack. It's a hack, yeah. Well, experimental equals hack, right? Let's be honest. It does. It sounds more complimentary, right? They're doing something cool, helping science. But yeah, no, I think that's a valid concern, and that brings up the point of the mixed environment, why probably it'll be a while before, if we can't access SRLV or DPDK or VPP or whatever, how are we going to run some of these network functions? But I do think these are things we need to push on and address. Yeah.
Especially for us, we have a lot of network processing and just the lack of support for NICs, SNCC assignments, DPDK. This limits our ability to go to kind of containers in general just because of these problems.
So I guess then the kind of question is, how do we drive? We still want to drive the vendors to look at solving these problems, right? We still want to drive the community. Let's not just put it on the vendors, but we want to drive everybody to solve this issue, right? And then also, like, when we start talking about mixed environments, are we assuming that if we're solving a lot of these performance issues that we're not doing it on top of a VM, we're not layered?
Right.
Are we assuming that we're giving Kubernetes bare metal access, or are we actually going to pass up the stack this offload, right? Or down the stack, however you want to phrase it.
Doesn't matter. Is it just another execution environment? It happens, somebody configured it that way.
It matters because you have to orchestrate it.
So those are all issues, but I want to mention, and anyway, the in-service upgrade, it's very crucial, and also high availability. And those two are, to me, is now, of course, depends on the application, depends on the location, and all these is concerned, but they need to be addressed.
Yeah.
Say that again, please.
The things you mentioned, high availability and in-service upgrades, are they specific to Kubernetes, or are they generic issues with bare metal, any kind of infrastructure? Or does Kubernetes get in your way?
It is tied to all. I don't know how you implement, and depends on the implementation, I believe. But in general, that needs to be addressed. So if I say, I have a container, and if I'm going to manage the container with Kubernetes, yeah, it's tied together. If I'm managing the containers with something else, then the container itself needs to figure out how to do the high availability. So
I'm going to flip the question, and you guys can correct me if I'm wrong a little bit. How do we get these workloads that aren't traditionally cloud native to be cloud native? Because by default, when we get to cloud native, we get a lot of that other benefit that you're looking for, right? So like we've had a lot of internal discussion around this. And for example, one of the, maybe we're crazy, but one of the crazy things we're doing right now is we say that the maximum life of a container is 7 days, right? And so we're actually forcing a redeploy, you're distributed across minimum replica 3, all this type of policy around it, but no matter what, a container doesn't live 7. I'd actually like, there's others in the industry like Netflix and whatnot that actually limit their VM or container to 1 day, right? And they don't even do garbage collection because it's only a 1-day life on the VM, right? So there's advantages to that model, but it's a very different mindset for the application you're onboarding, right? So what does that mean, right? So in the VM world, we've pretty much given up that we might say you need to do all these cloud native type things, but we didn't have enough checks and balances that were automated into the system to enforce that, right? So we're trying to create a new world in our place where, hey, you want to play in this new environment. You don't have to play in the container environment. You want to play here, right? We're not going to allow you to onboard pets into our kettle environment. We're not going to allow you to onboard that workload, right? Because by default, you're actually going to be evicted every 7 days. You can't handle that. Don't run here, right? So, and I would probably say like the VNFs are probably especially guilty of not being able to handle some of these things, right? So, that's got to be part of the culture change we say as you're coming into this new world. How do we actually get you to be cloud native and thinking in these ways and solving these problems in new ways? So I get that a lot of them are going to be hard problems to maintain, that you're serving customer traffic, no downtime, and still replacing infrastructure all over the place. So I'm not saying it's an easy problem.
Well, I would say this, right? You're not going to have a cookie cutter. Everything is going to be same, every implementation. I would say that it will be specific to the certain applications. So therefore, maybe one implementation could be not highly available because for certain applications, so targeted applications. The other one maybe has to be high available. But the point here is you got to have those options to be chosen.
Cool. We have 5 minutes left. Anybody with specific topics they want to address before we close out? All right, well, I guess we can let everyone go 5 minutes early. Thank you, everyone.